Good evening. Today, me and my friend will present our task 3 for subject SCES3274 Primary Science Education. This is me and my friend Nur Syuhada binti Mustafa, Lili Alisha, anak perempuan Sarudin, and me, Hamida, anak perempuan Halim. Scientific Skill Assessment. As we know, scientific skill assessment refers to the process of evaluating students' scientific skill, not merely their theoretical knowledge. This means scientific skill assessment refers to the systematic process of evaluating students' ability to apply scientific concept and method rather than merely testing their memory of theoretical understanding. And it focuses on the student ability to apply the scientific method. It's focused on the student ability to apply the scientific method, which is it focuses on observing how well students can use scientific process in real life or experimental context. In the primary school standard curriculum KSSR for science, these skills are known as basic science process skill and integrated science process skill, which form the foundation for developing scientific thinking and science literacy among students. And this is the importance of scientific skill assessment SSA. First, to strengthen problem-solving skill. Scientific skill assessment often involves solving real or experimental problems, which is helps students develop the ability to solve real-world and experimental problems by applying the scientific method. Instead of just recalling facts, students are encouraged to think logically, identify problems, and find solutions through the investigation. For example, during an experiment to determine which material is the best insulator, students must form hypotheses, design tests, and interpret results. These problem-solving skills are transferable and valuable beyond the classroom. For instance, using data to decide how to conserve energy at home or how to grow healthier plants in different environments. Second, to develop critical and analytical thinking. Through skill-based assessment, students learn to analyze information, draw conclusions, and evaluate evidence. Which means it can encourage students to question, reflect, and verify information rather than accept it at face value. For example, when students record result from an experiment, they must identify patterns, compare outcomes, and explain anomalies. They also learn to evaluate whether their experiment was fair or whether the results support their hypothesis. And for the third one is encourage understanding beyond memorization. By assessing scientific skill like observing, experimenting, and interpreting data, students learn how science works, not just scientific facts. This means instead of merely remembering scientific terms or theories, students engage directly in the process of doing science, which is observing, experimenting, measuring, and interpreting data. For instance, rather than memorizing that, for example, plants need sunlight for photosynthesis, students could conduct an experiment to observe plants grow under different light conditions. Through this experience, they gain a deeper and more meaningful understanding of the concept.
Understanding scientific skill assessment. Skill that allows students to question things and find answers systematically from simple to complex skills. Scientific skills are a set of transferable abilities used to gather information, solve problems, and conduct investigation systematically. Focus on assessing skills rather than knowledge alone. For your information, they are broadly categorized into science process skill or mental and thinking skill and manipulative skill or hands-on skill. Thus, in science process skills also divide into two, namely basic science process skill and integrated science process skill. Basic science process skills known as a mental and thinking skill. So this is detailed about SPS. Firstly, observing. Observing is the most basic and fundamental of the process skills. You can compare, classify or perform the other process skill without being a good observer. Using the five senses such as sight, smell, touch, taste and hearing to gather qualitative and quantitative information about objects or events. Next, inferring. Inferring is making a reasonable explanation or interpretation of an observation based on past experience or data. Inferring always using questions like how or why to explain or understand something that is not directly observed. For example, a plant near the window grows taller than one in the shade. The inference is the plant near the window gets more sunlight, which is help it grow faster. So, observation plus reasoning using pure knowledge leads to inference. Next, classifying. Classifying is a group objects or event based on shared characteristic or criteria, which is it helps scientists organize information so that patterns can be recognized and studied more easily. For example, classifying characteristics like looking at features such as color, shape, texture, size, behavior, and so on. Next, measuring using numbers, it means determining the quantity, size, length, mass, temperature, time, or volume of something using standard, unit, and instrument. It involves using number and measurement tools accurately to collect data in experiment. For example, if you want to measure temperature, you need to use thermometer and the unit of that is degree Celsius. Next, prediction. Prediction is the process of using past observation or data along with various scientific knowledge to forecast event of relationship. But if a statement not based on observation, it's not prediction. It's called guess. For example, if a magnet is brought closer to a paperclip, the paperclip will move toward it. So the purpose of prediction to help plan, investigation or experiment match the result. Next, communicating. Communicating is about expressing idea in many forms, such as orally, in writing, or with graph, diagrams, tables of data, or photograph. For example, describing the change in height of plant over time in writing or through graph. The purpose of communication to make result clear, organized, and understandable. Lastly, in basic science, process skills are a space-time relationship. It is about describing change in position, direction, shape, size, volume, weight, and mass over time. For example, a pendulum swings back and forth in equal time intervals. Purpose of space-time relationship happen to help students understand motion, grow, and change over time. To good analytical and observation skill, and to connect time, distance, speed, and direction in scientific reasoning. In short, this about how things change with time and space. Next, integrated science process skill have a 5 term. First, interpreting data. These include collecting information or data, organizing them, and finding pattern or relationship to arrive a conclusion. And organized data use graph like bar graph, life graph, and pie graph. Second is define operationally. This is how we decide to measure the variable in the experiment. In other words, it's explaining what something means in terms of how you measure or test it. For example, group of grade 6 student is conducting study whether running every day will affect the person endurance. So, the variable endurance may be defined as distance a person could run without stopping, number of hours a person could run. Next is control variables. A variable is any factor that can be changed, controlled, or measured in any experiment. First, independent variable. This is what you decide to change in the experiment. Second, dependent variable. This is what you observe or measure is in an experiment. Third, control variable. This is what you keep the same during the experiment. Next is formulating hypothesis. A hypothesis is an educated guess. It is proposed explanation for some events or problem. This suggests ideas that has to be tested through experiment, such as null hypothesis, state that there is no relationship between phenomena under consideration or that there is no association between two groups. Alternative hypothesis state that there is relationship between two selected variables in a study. Next, experimenting. Experimenting is the process of planning and conducting a fair test to find out the relationship between variables and to test a hypothesis or prediction. It involves using several science process skills together, such as observing, measuring, classifying, predicting, and communicating. In simple words, experimenting means doing an investigation to find answer to scientific question. Next, manipulative skill are the practical, hands-on, or psychomotor abilities that enable a person to perform experiment and scientific investigation effectively and safely. First, using and handling science apparatus and material properly and carefully. Second, handling specimen correctly and carefully, including living ones. For plant specimen, if you want to observe the exterior, then the observation should take place in habitats. If leaf or flower samples are needed, only take the quantity of the needed. Second, drawing specimen and apparatus accurately using correct scales and labels. Sketches must be accurately using the correct and appropriately scale. Scientific drawing must be labeled sharp, accurate, not color or darkened. Drawing must also not be in 3-dimension drawing. For example, drawing include a beaker with water half full. Next, cleaning science apparatus the right way. Wash glassware with warm water and soap. Then rinse several times with tap water, finally with distilled water. Place all the waste material in appropriate disposal container. And the most importantly, do not throw waste in the sink unless instructed by the teacher. Lastly, storing science apparatus and materials properly and safety. Next, implementation in Malaysia primary school. In Malaysia primary school, the assessment of scientific skill is integrated into the classroom-based assessment or PBD system. After UPSR since 2021, this involves continuous, formative and summative evaluation conducted by teacher during the normal teaching and learning process, guided by the curriculum standard Sekolah Rendah (KSR) curriculum. Next, the key features of the assessment implementation. First, integrated approach. Scientific skills are not assessed in isolation but are embedded within practical work and inquiry-based learning activity across various science topics. Next, teachers' role. Teachers play a crucial role in planning, conducting, and monitoring student assessment. They make professional judgment about student mastery level based on ongoing observation and interaction in the classroom. Next, performance standard, mastery level. Assessment is determined through performance standard, typically categorized into 6 material level. Level 1 to 6. Teacher evaluate student ability to apply knowledge and skill and track their progress through this level. They employ various methods to assess this skill. First, observation. Observe student during practical activity to guide them ability to handle equipment, follow procedure and work safely. Second, questioning and discussion. Using dialogue to probe student understanding and interpretation of data and observation. Last, work sample. Reviewing student work such as experimental reports, diagram, tables, and graph to assess communication and data interpretation skill. The shift towards classroom-based assessment allows for a more holistic and flexible evaluation of students' scientific skill, ensuring continuous feedback and improvement in the teaching and learning process.
Next is about contemporary challenges in education affecting scientific skills assessment. The first challenges is limitations of facilities, materials, and practical laboratories. The first is about limitation of facilities, lack of basic laboratory equipment, for example, thermometers, microscope, and digital scales. Next is about materials, lack of experimental materials and safe chemicals. For example, iron fillings, magnets, and lime water. Next is about practical laboratories. It is about limited and unsafe laboratory space. For example, narrow laboratory space. In relation to the features of an unsafe laboratory space, such as lack of ventilation systems or basic safety equipment such as fire extinguishers, first aid kits, and safety goggles, all of which are essential for conducting basic science activities. The second challenges is teachers' professional competence and assessment literacy. This is because not all teachers possess an adequate level of knowledge and skills to design, implement, and interpret the assessment of scientific skills accurately and validly. Teachers experience a lack of specialized training in the assessment of scientific skills. As a result, teachers may assess based on general observations without clear guidelines. Next, teachers face challenges in ensuring that the assessment instruments truly measure scientific skills, for example, observing and making inference. Therefore, without a clear understanding of validity and reliability, assessment results may become inconsistent among teachers. Next. The next challenges is tendency to focus on written tests. The education system in Malaysia still shows a strong tendency toward examination and written test-based assessment rather than skill or practical-based assessment. This is because the school is emphasis on academic achievement and examination results. For example, teachers focus more on objective questions and factual scientific knowledge. These situations creates a teaching to the test culture where students are trained to answer questions rather than to think scientifically. Number 4, the next challenges is large class size and teacher workload demands. Large class size and excessive teacher workload constitute major challenges in the effective implementation of the scientific skills assessment SSA in Malaysian primary schools. The excessive number of students per class. In many primary schools, a single class may consist of 30 to 40 students. Next, limited instructional time and practical assessment opportunity. The instructional time allocated for science in primary school is relatively limited, typically 1 to 2 periods per week. Then the high teacher workload. Teachers are not only responsible for teaching but also for performing various non-academic tasks such as data management, co-curricular activities, and documentation related to the classroom-based assessment. Next. Next challenges is digital learning challenges. Limited feasibility of practical skill assessment in online environment. This is because scientific skills such as observing, experimenting, or manipulating variables are difficult to measure through digital platforms. In an online setting, these skills cannot be authentically demonstrated or assessed. In this era, teachers often replace practical tests with quiz or written assignment, which fail to capture inquiry and process skills. Next. Next is about impacts of contemporary challenges on science education. The first is about limited hands-on learning opportunities. This is because due to a lack of laboratory equipment, materials, and teachers will conduct fewer practical or experimental lessons. So this will restrict students' chance to engage the inquiry-based investigation and real scientific exploration. Next, second, decline in students' scientific literacy and critical thinking. This will cause the student become less able to ask questions, analyze data, or draw conclusions based on evidence. And this is also weakens their ability to think critically, solve problems, and apply inquiry-based reasoning. Because without hands-on or inquiry-based learning, students struggle to solve real-world problems using science. The third one is about lower student engagement and motivation in science. A lack of practical and experimental exposure reduces students' curiosity and interest in science. As a result, fewer students are inspired to pursue science-related subjects or careers in the future. Next. The next one is about decline in student progression into STEM pathways. This discourages this discourage them from pursuing science subjects at the secondary or tertiary level. Students struggle to handle higher level science and mathematics content. This will reducing their red lines for STEM fields. This trend poses long-term challenges to Malaysia's innovation capacity and economic competitiveness. The next one is about inconsistent and less reliable assessment of scientific skills. Why did I mention about this? Because teachers' limited assessment literacy and high workload lead to the inconsistent marking and clear evaluation of students' scientific skills. Because of heavy workloads and large class size, teachers are often assess students based on general observation instead of clear criteria. Next point is this will affect the accuracy and fairness of learning outcomes. So this problem will cause their marking become inconsistent. This will affect their fairness and makes it hard to measure students' real science skill accurately.
For the last point is recommendation and insight. There are three recommendation and insight. There are, which is educators, administrators, and policymakers. For educators, implement ongoing formative assessment during experiment, which means instead of assessing students only at the end of the topic, teachers should observe and evaluate student progress continuously during practical work. This allows for immediate feedback and improvement. For example, during an experiment on the effect of light on plant growth, a teacher can assess student observation, measurement, and data recording skills while they conduct the activity, not just based on their final report. For use self-assessment and peer assessment to encourage student self-reflection. This allows students to assess their own performance or that of their peers, promotes self-awareness and accountability. It helps students identify their strengths and weaknesses in scientific inquiry. For example, students can use a checklist to evaluate how accurately they recorded results or how effectively they collaborate in a group experiment. For third point, teachers can apply assessment rubrics that are aligned with scientific skill indicator in the curriculum, which means teachers should use rubrics that match the scientific process skill outlined that in the KSSR curriculum, such as observing, hypothesizing, and experimenting. This ensures fairness and consistency in assessment. Second, administrator. This means school leader and administrator are responsible for providing the necessary support to teachers to implement scientific skill assessment effectively. They can provide additional training, sufficient time allocation, and supporting materials to help teachers carry out scientific skill assessment more effectively. Which means teachers often need professional development to assess scientific skill effectively. Other than that, administrators also should arrange workshops, share teaching resources, and ensure sufficient class time for practical assessment. For example, school could organize training seasons on designing hands-on experiment. The third one, policymaker. Policymaker at the national or district level influence the framework and structure of SSA implementation. Policymaker can review and strengthen the classroom-based assessment (PBD) guidelines to ensure effective evaluation of scientific skill assessment, then support the integration of digital tools to enhance the practicality and efficiency of conducting practical assessment. Which means policymakers should promote the use of technology such as online rubrics, digital portfolio, or virtual lab simulation to make SSA more manageable and engaging. For example, using digital apps like Google Form or Padlet to record student observation and can make assessment more organized and time efficient. For the conclusion, is As we know, scientific skill assessment is essential for developing students who are scientifically literate and capable of critical thinking. To ensure effective implementation, teachers should receive continuous training on authentic and rubric-based assessment method. Authentic assessment means involves real-life tasks such as experiments, projects, or scientific investigation that require students to apply their understanding rather than merely recall facts. For rubric-based assessment means teachers provide clear criteria for evaluating student performance, ensuring fairness and consistency. For example, teachers may assess students by having them design a water filtration system using recycled material and then grading them using a rubric that measure creativity, scientific reasoning, and teamwork. For administration, should provide adequate time and resources for practical science activities, which means school administrator must ensure that teachers and students have sufficient time, material, and resources for conducting hands-on science activity. Without proper support, even the best assessment plans may fail. The third one, policymakers should strengthen school-based assessment system to reflect real-world scientific inquiry and 21st century competition. Which means education policymakers should enhance school-based assessment systems so they align with real-world scientific inquiry and promote 21st century skills such as communication, collaboration, and innovation. For example, the Ministry of Education might introduce national frameworks that encourage project-based learning and integrate digital tools like data analysis apps or virtual labs. That's all.